Okay, now let's go to the big screen, not the movie theater. Just when we show our math, right? So let's do a problem where I'm going to write, and then we're going to take a look how to create the equation. So the first thing that we're going to learn in linear programming is how to create the equations. Okay, the objective function, find out the decision variables, write the objective function, and write the constraints. That's the first thing that we're going to learn. After we learn that, we can start solving it. We can actually start to figure out what is the answer for that. I know you guys are going to be crazy. What's the answer? What's the answer? But first, we need to concentrate in the equation. If you do the equation right, you can find the answer. If you do the equation wrong, you're never going to find the answer, right? So let's take a look how to create the equations. Very, very, very important. So let's say this example, okay? You have Stratton Company that produce two basic types of plastic pipes. Three resources are crucial for that output. We have extrusion hours, we have packaging hours here, and we have an additive that we use for that raw material. Here is what represent 100 feet of pipe. We have products, so we have type 1 product, type 2 product, and that's how many hours takes of extrusion of, let's say type 1 takes 4 hours to extrusion. So, oh, heads up there, extrusion is a type of a process that it's used for plastic, right? So basically, plastic, you either, let's think about that like Coke bottle, plastic bottles, right? So you have a little thing of plastic that's thicker, and then you put some hot air, and you put it within like a mold, and you put that thing, put hot air in the middle, and that little thing will expand to the size of the mold that you have, right? So that's one type of plastic process. The other type would just be molding something. You just get it hot and you mold to whatever size you want it. Okay, so yeah, that's just parentheses there. Okay, so extrusion, one of those process. You have packaging, that's the other one. So type 1 product take 4 hours extrusion, 2 hours of packaging, and 2 pounds of additives. Okay, and then you have the data for type 2, and you have total resource availability. So I only have 48 hours of extrusion, and I only have 18 hours of packaging. Oops, I jumped one. So the first thing is going to be to decide what are my decision variables, right? What am I trying to decide on? So I cannot decide if I'm going to do extrusion or if I'm going to do packaging. I have to do that. What I need to decide is the amount of type 1 and amount of type 2 that I'm going to produce. So I'm going to write that, okay? So I have a variable to explain what that is. So x1, I'm going to call it x1, my variable that I'm going to create, is going to be the amount of type 1 product that I'm going to consume and or produce and sell, let's say. Produce and sell. X2, another variable that I'm going to create. Oops, I haven't seen that was outside. It's going to be the amount of type 2 that I'm going to it's that I'm going to produce and sell. Yes, I reduced a little bit to make it easier. Wow, that cell is horrible. Okay, so these are my two variables, and I'm going to call them x1 and x2. Now, what I want to do is decide the objective function. Okay, so objective function is again is going to be the formula that I'm going to use to find out what I'm going to maximize or minimize. Right. So now we're going to give it additional information. The goal is to maximize the total contribution of those two products makes to profit and overhead. Each unit of X1, which I know that's type 1, yields $34. Each X2 yields $40 off profit. For every specific value of X1, we need to find out the number to multiply the profit per unit, right? So now we're going to write down the objective function for this problem. So am I going to maximize or minimize? I'm going to maximize, right? So that's profit. And how do I write this equation? Well, it's a simple revenue equation, right? So it's going to be $34 times X1. For every X1 that I'm going to sell, I'm going to get $34 plus $40 times X2. For every X2, I'm going to get $40, right? And that's the formula, and that's just notation there, that I'm going to write. I need to maximize X1 plus X2, and X2 is going to be giving $40, X1 is going to be 35, right? So out of the bat, I say, well, X2 seems to be better to produce. It gives me more money. Well, let's take a look at that later on. Next step, it's going to be write down my constraints, right? And constraints, I'm gonna write subject 2. What constraints? Well, that 2 looks horrible. Yeah, sorry about my handwriting. You guys had to live with that for the whole semester. I had to live with that my whole life, so I mean, worse shape. Anyway, so what are the constraints? What things constrained my process? Well, the resources constrain the process, right? I can only have 48 hours of extrusion. Okay, so that's one constraint, but how do I write the equation to know if I'm going to hit that constraint or not? Well, for every x1, I know that it'll take 4 hours. For every x2, I know that will take 6 hours. And I know that the total have to be 48. So voila, that's the constraint, right? 4 times x1, so for every x1, 4 hours, plus 6 x2, voila, for every x6, have to be lower or equal than 48, right? And that will be my extrusion constraint. Okay? So again, you have to pay attention to those things. Linear programming is not an easy thing. You have to pay attention to those details, right? But you can get it. I know you guys are smart. So that's the extrusion. Packaging, the same things, but that's going to be 2 because that's 2 hours, right? Look there, right? Look there, look there. Packaging, 2 hours. So 2 hours of x1, every x1, 2 hours. 2 hours of x2 have to be lower or equal than 18. So I know you guys are getting it now, right? Because that is going to be my packaging constraint. And we're going to do some problems in class. We're going to practice that, okay? Additive, we have the numbers there. 2 times x1, so 2 pounds of x1, plus 1 times x2 is going to have to be lower or equal than 16. And that's the additive constraint, right? And I have these 3 constraints that I wrote for this problem. And basically, these are the equations, right? This is our first step. Understand how to build the math, right? So let me ask you, how many x1s can I produce? Well, if I think about, here, I can produce 12 x1s, right? And I'm okay with this constraint. It's going to be 48, 10, 12 times 4, 48. I'm good. But then if I put 12 here times 2, 24, then it's going to be higher than 18. So what I'm doing now is just figure out the math. Then I need to put in the software or the logic that we're going to use to actually find out the answer for this problem. But now I'm just creating the equation. And here you guys have, here you have the equation that actually, explain everything we did. But you need to know how to do that. If you have questions, let me know. Take a look back in the video, and we're going to train more in class, okay?